All right, welcome to lesson 3. Lesson 3 is going to be short on the lesson, a little bit longer on the examples because it's going to be a lot of math problems. We are doing half-lives. Now, if we were in class, we would be doing a really cool activity with Skittles or M&Ms or pennies or something to demonstrate half-lives. But unfortunately, we can't. I'll try to find a cool movie or cool little video about half-lives for you guys, just to mix it up as like an additional thing. But here we go. I'm going to go through a couple different examples with you, talk about what half-lives are, and then check for Kessel learning later. So half-life. This is the time it takes for half of the atoms of a radioisotope to decay. So it's in the name, half-life. So we start with 100%, and this is the amount of time it takes for us to get to 50%. So to decay by 1/2. When we calculate half-life, so after 1 half-life, 50% remains, or half. After 2 half-lives, 25% of the original remains. After 3, 12.5, and so on and so forth. This continues forever. We will never reach 0. We will just get much smaller and smaller and smaller and smaller as we go. Table N in your reference table on page 6 shows the selected radioisotopes and their half-lives. So I have a picture of that on the next slide. But this is just an image to see. After 0 half-lives, we have 100% of the parent isotopes. After 1 half-life, if we counted up all these dots, it would be 50-50. After 2 half-lives, we're cutting the maroon or like the red dots in half again. So we would only have 1/4 of those remaining, and we would continue on. This type of decay is considered exponential because of the curve we get at the end, and it also never reaches 0. So we start at 0 half-lives with 20 grams. We go down 1 half-life. We have 10 grams, then 5, then 2.5, and then so on and so forth until forever. So this is table N. So our half-lives are here. If you notice, there are different units. So D is day, just so everybody's clear. Y is year. And S is seconds. H is hours. We have some milliseconds on here. MS is millisecond. And I think we have some minutes on here. Min is minutes. I think that's everybody. All right, so these are our half-lives. So that's how long it takes for something to decay 50%, right? So we're going to look at a bunch of different practice problems. But first, the shorter the half-life, so those half-lives that are in seconds, less stable. They don't last that long. The longer the half-life, like those that are in years, they're much more stable. So shorter half-life, less stable. Longer half-life, more stable. All right, so we're going to look at a bunch of problems. I'm going to go through one. Then I'm going to put up a second one, tell you guys to pause the video, work on it for practice, and then go through the answer. So let's look at amount remaining. So this is the type of problem we're working with. So if a sample of I-131 has an original mass of 64 grams, what mass will remain after 32 days? So the first thing I want to know is I want to know how many half-lives have taken place. So I see that we have 32 days, right? So 32 days. I go to table N. And I see that my half-lives for I-131 are 8.021 days. So I'm just going to call this 8 days. Right? If I do the math, I get 4 half-lives. Okay, so 4 half-lives have elapsed. So now I would like to know how much remains. So we're going to cut 64 in half 4 times. So we go 64 in half goes to 32. Cut that in half, we get 16. Cut that in half, we get 8. So that's been 1 half-life, 2 half-lives, 3 half-lives. So we have to do one more half-life. So our 4th half-life, we end up with 4. So 4 grams will remain after 32 days. Right, so this is the order we're going with. We determine the number of half-lives, and then we just cut the original mass in half that many times. So let's look at a practice question. If cesium-137 has an original mass of 52 grams, what will remain after 150 years? So I would pause the video here, practice this, and then come back once you're done for the answer. So same thing. We have 150 years. That's how long we're letting this decay for. And table N tells me that my half-life for cesium-137 is 30 years. If I divide these two, I get 5 half-lives. So you're going to split 52 grams in half 5 times. So we have 52 goes to 26, 13, 6.5. There we go. Nope, 6.5 goes to 3.25, goes to 1.63 grams. So if we count up our half-lives here, we have 1, 2, 3, 4, 5. Okay, pretty straightforward. You're figuring out how many times it has halved, and then you're just dividing that many times in half. So let's look at fraction remaining. So same setup as the other one, but now we're just looking for what fraction or what percent basically remains. So we have cesium-137 again, mass of 52 grams, and I want to know what fraction remains after 150 years. So we just saw this, so 150 years, and our half-life is 30 years, so that tells us that 5 half-lives are happening. So from here, we're just going to see what fraction remains half-life. So instead of working with 52, we're going to work with the number 1, right? Because 1 is 100%. So we have our first half-life gives us half. Then we have a quarter. Then we have an eighth, a 16th, and 1/32, right? So if we count our half-lives again, we have 1, 2, 3, 4, 5. So same setup, but instead of dividing 52 in half 5 times, we're just figuring out what percentage remains. Okay, so let's, again, take a look at a practice one using iron 53 with an original mass of 52 grams and after 25.5 minutes. Remember, you can find your half-lives in table and in your reference table. So pause and work on this one. All right, so same thing. We're going to take the time that's passed. So 25.5 minutes has elapsed. And the half-life for iron 53 is 8.5 minutes. So this is giving us 3 half-lives. So same thing. We're just looking for what fraction remains. We're not looking for a number. So we have 3 half-lives. So if we have 1, we go to a half, which then goes to a quarter, which then brings us to an eighth. Right, so I'm just writing this out for you guys with the arrows to show you the progression. If you already know that 1/8 is dividing 1 3 times in half, go for it. Whatever works best for you guys. I'm just writing it out long ways to show you the best way to visualize it. So after fraction remaining, we're going to look at number of half-lives. So now we're going to be determining how many half-lives has happened, right? So let's look at technetium-99. So how many half-life periods will it take for 50 grams of technetium-99 to decay to 6.25 grams? So what we're going to do is we're going to find the number of half-lives by halving the original amount until we get to the final mass, right? So we're actually going to be working backwards here. So we are starting with 50 grams. Sorry, I'm jumping ahead of myself to the next type of problem. So we have 50 grams, and we want to see how many times we divide that to get to 6.25. So we cut this in half until we reach that final goal, right? So 6.25. So how many half-lives did we have here? We had 1, 2, 3. So our answer is 3 half-lives. So in this problem, we're just looking at what we're starting with and what we're ending with and see how long it takes us to get there. Okay? So again, take a second, practice this one, come back, unpause when you're ready. All right, so we're looking at iodine 131, decaying from 100 grams to 25 grams. So this one should be pretty straightforward. 100 is an easy number to work with for us. So there we go. So we have 1, 2. So our answer is 2 half-lives. These ones are pretty straightforward of all the half-life problems we're going to be working on. So the next ones we're going to look at is we're going to look at half-lives. So how many half-lives, or what is the half-life, right? So our first question here. So what is the half-life of a 500-gram sample of a radioactive element if 125 grams remains after 20 hours. So with this one, they didn't tell us what the radioactive element was, right? So we can't just go to table N and say, oh, it's 12 hours or whatever it is. So we have to figure it out on our own. So our first step is we're going to find the number of half-lives. So we started with 500 grams, and we ended with 125. So we're going to divide by 2 until we get to 125. All right, we're there. So this was 1, 2. So 2 half-lives. So we're going to write this down so we remember. So 2 half-lives, done. So our second step, we're going to divide the time elapsed. So we had 20 hours was the time elapsed by the number of half-life periods, right? So we had 2 half-lives. So this is going to tell us that we have a half-life of 10 hours. Okay? So find the number of half-lives and then divide the total time elapsed by the number of half-lives, and you get what your half-life is. So let's take a second to work on this one. Remember, pause the video. You don't need table N for this one. So, when we're reading this problem, so we want to know what the half-life is of a radioactive sample that started at 250 grams and ended at 7.8 grams after 14 days. So let's start with finding how many half-lives have passed. So we're going to start with 250. Divide this in half until we get to 7.8. So this is going to be a little bit of a longer one. And then we keep going, almost there. You can also tell when you're almost there as you're getting through this. So how many half-lives did we have? We had 1, 2, 3, 4, 5 half-lives. So now we're looking for what the half-life is, and we had 14 days elapse. So we're going to take 14 days, divide this by 5, and we get a half-life of 2.8 days. Okay, again, a lot of these are pretty straightforward, and you kind of get into the habit of them the more you do them. We have 2 more types of problems left that we're going to work on. And then please check out your practice learning. If you guys need more practice questions, please let us know. And again, I'm going to post an additional Half-Life, just extra video for you guys to watch. All right, so now we're going to look at original mass. So now we're going to work backwards and find out what our starting mass was. So technetium-99, we use this as an indicator with brain tumors. The half-life is only 6 hours, so it's quick. It leaves the body relatively fast. So if 10 micrograms are left after 24 hours, how much was administered originally? So we're going to start with figuring out how many half-lives we had, right? So we were told that the half-life is 6 hours, and the total time elapsed was 24. So we're going to have 24 hours divided by 6 hours, so that gives us 4 half-lives. So now we're just going to work backwards. So we were originally dividing the original mass by 2 each time. So now we're going to multiply the final mass by 2 each time, 4 half-lives. So we started with 10 micrograms, right? Or actually, we ended with 10 micrograms. If we double this, we get 20. We double that, we get 40. So that's 1 half-life, 2 half-lives. We double that for our third half-life, we get 80. And we double that for our fourth and final half-life. And originally administered to the patient was 160 micrograms, I'm sorry. Same concept, just now we're multiplying by 2 instead of dividing by 2. So try this one on your own and then come back. All right, you should be on pause by now, so let's take a look at this one. So our time elapsed was 37 hours, and 2 grams remained unchanged, so 2 grams were left of a sample of potassium-42. So how much was in the original sample? First, I need to go to table N and find my half-life of potassium-42, which is 12.36. I'm just going to double check my periodic table. 12.36 hours. Okay, so we had 37 hours elapse. We're going to divide this by 12.36, and we end up with 3 half-lives. So remember, I'm looking for what was the original sample. So I'm not going to be dividing 2 in half 3 times. I'm going to be multiplying it by 2 3 times. So if I start with 2 and I go through 1 half-life, I get 4. I go through a second half-life, I get 8. And on my third half-life, I get 16 grams. So we started originally with 16 grams of potassium-42, and it decayed down over time. Okay? Last but not least, we have our time elapsed. So for this one, we're trying to figure out how much time has gone by given the decay we have. So our first step, as per most of these problems, is we need to find out how many half-lives happened, right? So I started with 400 grams, and I was left with 50 grams. So let's work our way down. So 400 divided by 2 goes to 200. That's 1 half-life. Our second half-life gives us 100. And our third half-life gives us 50. So we went through 3 half-lives here. So we're going to look up on table N what our half-life is of P32. So if I go to table N and I look at P32, I have a half-life of 14.28 days. Right? So I know that this sample decayed over 3 half-lives, right? And 1 half-life is 14.28 days. So I'm going to multiply the 2. And this is going to give me the length of time that took place. So this was over a course of 42.84. My decimal is not working. There we go. 42.84 days. Right? So this one, we're given less information, but we're still able to come out with all the information at the end. Right? So we're always going to figure out how many half-lives we went through. Then we're going to use that table N on page 6 and multiply the time remaining. Alright guys, I know this was a lot of different types of problems. They all are kind of very similar to one another, so you should start to notice patterns. Excuse me. Please, please, please reach out if you guys need any help or would you like additional practice with these kinds of problems. Otherwise, keep an eye out for Castle Learning. This is our last lesson for this unit, so if you have questions, please ask them now because our next assignment will be the end of unit assessment. All right, guys, stay strong, keep doing what you're doing, and you know how to reach us if you need us.